All right, this example is taken out of your workbook. It's a question in the workbook, but I'm going to work through it as an example. So it's got two buildings here, building 1 and building 2. And it says from the top of a 200-meter building, so the smaller one is 200 meters tall, and it gives you the angle of elevation, which is 40. Angle of elevation goes up. And then it says the angle of depression, which goes down, is 25 degrees. Now the angle of depression down 25 degrees is only the angle here. And the angle of 40 degrees is only the angle right to that horizontal line in between the buildings. What it wants you to find out is how tall the second building is. In order to do this, we need to find kind of two things. We need to have this value x, which we have over here is actually 200. And we need to figure out what this value y is here, and then we can add the two together. That's essentially what I want to do. But before I can find y, yes, I have 40 degrees down here, and yes, I know that y is opposite 40 degrees, but I don't have any other piece of information for that top triangle. I don't know what the bottom horizontal distance is between the buildings, and I don't know what this side length is here, the hypotenuse. So I'm missing too much information. I need to figure out what one of those two sides is first before I figure out what angle or side y is. How do you think I'm going to do that? Well, you might be answering to yourself, what if I find out the horizontal distance between the two buildings? Because I know that 200 meters is the opposite from 25, and the horizontal distance, let's call z. So I have the opposite, and I need to find the adjacent, because the right angle is here, the hypotenuse would be the slanted side. So I have the opposite over the adjacent, so I'm going to be using tan. I'm going to be using tan of my angle, 25 degrees. That's going to be equal to my opposite, which is 200, divided by my adjacent, which is z. Tan of 25 degrees is 0.466, so I get 0.466 is equal to 200 divided by z, or z. And then in order to solve this, usually what I do is I switch the place of the z and the 4.66. I don't know. Some people, what they do is they multiply by z and multiply by z. So they get like 0.466 z equals 200. Because when I multiply by z on this side, the z goes away. And then I can see clearly, oh, okay, I need to divide by 0.466, divide by 0.466. But it's the same thing as switching the places of z and 0.466. That's just kind of a fast method that I do, and I don't have to go through this. So 200 divided by 0.466 is equal to 429. So z is equal to 429 meters. And that is the distance from here all the way to here. The distance between the buildings is 429 meters. But now I can use that with my angle 40. Because now I'm trying to solve for, again, the opposite side, and I have the adjacent. So again, I'm going to use tan. But this time I'm going from 40 degrees. So I'm going to use tan of 40 degrees is equal to y over 429. Notice that in this case my z was on the bottom just because it happened to be the adjacent. In this case, the value that I got for z happens to be on the bottom again. But keep in mind that where the opposite and where the adjacent is. The opposite is y, the adjacent is 429. So I work this out, I get tan of 40 degrees is equal to 0.84. So 0.84 is equal to y divided by 429. In this instance, to get rid of the 429, I times by it, 429, that's a 4, I times by 429 on that side. So I times that value by 429, I get 300, and we'll round to 360. So that means y is equal to 360 meters. I have the distance for x. I just figured out that y is equal to 360. to figure out the height of the building, what do I have to do? Oh yeah, that's right. I have to add them both together, right? So I get the height is equal to 200 plus my 360, which is equal to 560 meters. And that's how you solve the question for the height of the building.